Hello, Math 140. This is Cindy Enrique, and we are going to start our online learning. So we are starting on Chapter 5, Page 1. And then before we actually dive into Chapter 5, we're going to have to review a little bit in Section 1.1, reviewing our rules of exponents, roots, and order of operations. So hopefully you remember that order of operations, we do that following a particular sequence. That sequence is usually referred to as PEMDAS, or please excuse my dear Aunt Sally. Now, what's kind of misleading about PEMDAS is you think that P is just for parentheses, but it's really parentheses, brackets, braces, absolute values, a square root, a fraction, or basically really it's any grouping symbol, okay? That's what the P stands for in PEMDAS, any grouping symbol. E is for exponents. It's M or D, multiplication or division, whichever comes first, reading left to right. Same thing with addition and subtraction, whichever comes first, reading left to right. So for example, and you can plug these into your calculator, but -1 times -1. Hopefully, we remember that this is really -1 times -1. So it's a negative times a negative, which gives us a +1 as our final answer. Versus over here, the square only belongs to the 1. That is being multiplied. So the thing that's kind of hanging out here is actually the negative. So the negative is just hanging out. So I'm going to have, sorry guys, I'm getting used to this. So I'm really going to have 1 times 1 times a negative. So I have 1 and a negative hanging out on the outside. And of course here I have a negative times -1 times my -1. So I know that these two give me a +1, but I still have a negative hanging out on the outside. So I know that my final answer is actually going to be -1. Okay? And hopefully you remember that absolute value is the distance from 0. So absolute value is distance from 0. And distance can never actually be negative. So my answer here, I'm going to have my answer here as +1. Here, -1, if I'm thinking about it on the number line, here's 0, here's -1, here's +1. Well, I know that -1, the distance from 0 is just 1. Now, this is a little bit confusing. What we have here is we actually have an absolute value and a negative hanging out on the outside. So we have a negative hanging out on the outside. And we have the absolute value of -1. So this inside, the distance is negative, but we are still going to have that negative hanging out on the outside. So that tells us that our final answer here is going to be -1. So hopefully that's a quick little reminder on how to do our negatives and our order of operations. So when it says find the square roots of the given numbers, well, if I were to find the principal square root of 36, I'm saying what number, if I square it, is going to give me 36. And the principal square root there would be 6. 6 times 6 is 36. Here, if I think about it, the square root of a -25, well, it's negative inside the square root. So, depending on your homework, you can either say that this is going to be no solution, or if your homework, if we have talked about imaginary numbers, then we can say that it's 5i. It just kind of depends, but I believe this is going to be no solution. The other thing that we're going to learn in this chapter is the radical sign. So we know that the radical, or the square root, really represents the principal square root. And we know that a fraction inside can be split top and bottom. So what do we have here? We have the square root of 144. Well, the square root of 144 is just going to give me 12. Okay. Here, I can actually split this. So I'm going to have the square root of 49 up on top and the square root of 81 on the bottom. So the square root of 49 is 7, and the square root of 81 is 9. So my answer here is going to be 7/9. If I have the square root of negative 81, again, this is negative inside the square root. So we're going to say it's a non-real solution. This is an imaginary number, so we're going to go ahead and say it's a non-real solution. Now, that square root of 0.81, well, we can just put that into our calculator, and we already know that the square root of 81 is 9, so really the square root of 0.81 is actually going to be a 0.9. I just plugged that into my calculator. Okay. Down below we have some practice problems. So we have the square root of 121, and we plug that in, it's going to be 11. Again, for this one, I can split it, the square root of 81 over the square root of 169. So we already know that the square root of 81 is 9, and the square root of 169 is actually 13. So my answer here is 9/13. Here, what we're going to use, since we have different operations, we're going to have to pay attention to our order of operations, or better yet, our PEMDAS, if that's what you like referring it to. So here, we really want to pay attention on what we're going to be doing first. So, okay, well, I know that I have division and multiplication, whichever one comes first. Well, it looks like the division is going to come first. That's the first thing I'm going to do. So I have a negative 34 plus, so this is the new thing. I'm going to have 12 divided by a negative 3, and that gives me a negative 4. And I still have times 5. So the second thing I'm going to do here is multiplication. So I have negative 34 plus, and now that multiplication, negative 4 times 5, gives me a negative 20. From here, I'm just going to be adding some negative 34 plus a negative 20, and that gives me a total of negative 54 for my final answer. For the next one, in our PEMDAS, we do have a sort of parentheses. That's going to be our absolute value. So that's going to be the first thing that I really want to think about. So I have negative 2 to the 4th power plus 4. And don't forget that that 4 is actually being multiplied since it's inside the absolute value. So inside the absolute value, I'm going to have 18 minus 24, and that gives me a negative 6. So negative 2 to the 4th power plus 4. And now, since I'm doing the absolute value, I can think of this as it's being multiplied, so I can still think of it as multiplication. The absolute value of negative 6 is positive 6. So now I've done my parentheses, or my absolute values. The next thing is going to be my exponent. So now I want to think about my exponent over here. So negative 2 to the 4th power. So because there is not any parentheses around the negative 2, I know it's going to be negative. So it's a negative 16 plus 4 times that positive 6. Well, I know that that multiplication is stronger than addition, and 4 times 6 is actually 24. And I'm going to add to it a negative 16, And that is going to give me a positive 8 as my final answer. So positive 8 is going to be my final answer for that one. Okay? And then we have part C. So for part C, again, we're having our PEMDAS. So I know I'm working with my order of operations. And if you need to, you can always put it down. And remember, you're always allowed to have your calculator. If you put this into your calculator, I think it does it for you. So let's think about this. Negative 5 squared, well, that's 25, minus 8, and I have my brackets. And inside here, I'm going to have my 6 plus my 3, which is a positive 9. So I did this, and I did this. Okay. Just going left to right, I realized that I'm going to have my negative 5 squared, which is positive 25. And I know that inside my order of operations, I have parentheses inside brackets. So I wanted to do that first. And I still haven't done anything with that. And I have the square root of 36. So now I have 25 minus 8. And on the inside of those brackets, I have 4 minus 9, which is going to give me a negative 5. And I can also think about this square root of negative 36 as being a 6. That's the principal square root. So now I'm left with 25. And I have to be careful here because what I'm doing is I'm actually going to be multiplying those two numbers together. So when I multiply those two numbers together, a negative 8 times a negative 5, well, a negative times a negative is a positive. So now it's a positive 40 that I'm going to get minus 6. So now it comes down to 25 plus 40 minus 6. And I end up getting a positive 59 as my final answer. Okay. So down below we have some practice problems. If you guys want to try that, be my guest. You also have a bunch on your homework. So I'm not going to really sweat the practice problems right now. We have quite a few practice problems now, don't we? Okay. Alright, so now we're going to get into section 5.1, which is actually now our rules of exponents. So this is new. So we have our 5 basic rules of exponents. So we know that we can apply these rules and they're always going to work. Okay, this is kind of like our laws of exponents, shall we say. So we know that if we have a fraction and it's to the nth power, then that nth power gets distributed on the inside. For example, if I have 2 over 3 to the 5th power, that's really to the 2 to the 5th over 3 to the 5th. That is how we would use that. For the second one, the rule number 2, I'm looking at that and it's saying, hey, whenever I have a negative exponent, it just means to move it on the opposite side. So, for example, my rule 2. If I have 5a squared b to the negative 3, well, it tells me that the only thing that's a negative exponent is that b power. So when I rewrite this, that 5a squared, they all have positive exponents. Leave it alone. The only thing that had a negative exponent gets moved to the opposite side. So that b to the 3 that was in the numerator, now it's in the denominator. Okay, so that's my rule number 2. So rule number 3, what that is doing is it's actually kind of doing it in reverse. If it's negative on the bottom, then you bring it to the top. And that's why I say if you have a negative exponent, bring it to the opposite side. So for example, for rule number 3, if I have 4a to the 4th b squared, 5c squared d to the negative 1. Well, it tells me that the only thing that has a negative exponent is here, so it has to be moved to the opposite side. Every single thing stays the same. So I have the 4, the a, 4b squared, 5c squared, and now that d, because it was the only thing that had a negative exponent, it's sad. Please move me to the opposite side so I can be a happy positive exponent, d to the first power. So that is how we make our exponents happy, by making them all positive. And here, rule number 4, this is probably my favorite rule because it's so simple, yet it's very, very deep. Anything in the world to the 0 power is 1. For example, if I have 5 alpha beta to the 6 power, looks kind of crazy, I know, this is calculus I'm using, but what helps is it's to the 0 power. That 0 exponent tells me that all that craziness just goes to 1, not a problem. Okay. And for our last rule, rule number 5, it's just saying, hey, if you have a fraction and everything's in parentheses to a negative exponent, then what you can do is you can actually just flip everything on the inside. For example, if I have 5 over 3, and I have, let's say, those accordingly, and it's to the negative 1 power, then what can happen, instead of distributing everything, I can just flip everything. So this is 3b 5a to the first power, which is just 3b over 5a. So that's what we're doing here. So this is just a short mini example to show you how to understand our examples of exponents. So here we go. We are now going to be further exploring these rules of exponents. So we have this exponent of 3 with a fraction. So I'm going to distribute that 3. So it's 4 to the third and 5 to the third. So 4 to the exponent of 3, so 4 times 4 times 4 is actually 64. 5 to the exponent of 3, that's 5 times 5 times 5, is 125. So that's going to be my final answer. Ooh, this is my favorite one. This is where it's just saying that it's to the 0 power, so my answer is just 1 by definition. This one is telling me that I have a negative exponent. So because I have a negative exponent, it's kind of telling me that it's sad, it's in the wrong spot. So I can really think of this as over 1, okay? So I really have negative 5 to the negative 3 over 1. So in order to make it happy, I'm going to bring that negative 5 to the bottom to the third power. Now, everything in the numerator got brought down to the denominator. So by default, I need to have a 1 up on top. So now I have negative 5 times negative 5 times negative 5. Negative 5 to the third power is a negative 125. So that's going to be my final answer. For number 4, I see that A is the one with the negative exponent, but 2 is actually positive. So I really have 2 times my A to the negative 6. So what ends up happening is a lot of students want to move everything, but you only move the thing that has the negative exponent. So 2 is fine, leave it alone. So that A needs to go down to the bottom so it can be a positive, happy exponent. Again, for number 5, we have a negative exponent. So that means we're going to move it to the top. And when we move it to the top, I'm going to have 3 to the 4. So this is 3 times 3 times 3 times 3. 3 to the 4th power is a positive 81. For number 6, this is an interesting one because it's negative and it's to the 3rd power. So if we're going to be using that rule since it's negative, well, then I can say that this is really going to be 4 to the 3rd. And my power here is now going to be a positive 3. The reason why is because this was negative. And so I moved everything. And now I can distribute. So now this is 4 to the 3rd and 3 to the 3rd. Well, from number 1, I know that 4 to the 3rd power, 4 cubed is actually 64. And I know that 3 to the 3rd power is going to be 27. So my final answer there is going to be 64 over 27. Down below we have some practice problems. Again, you can either try these out on your own. You're also going to have plenty on your homework as well. So I'm not going to stress about the practice problems. They're for you to try anyways. So our scientific notation. This is where it gets kind of interesting. We can either express really large numbers by using scientific notation or really small, tiny numbers using scientific notation. Astronauts and people on NASA, somebody who works with really microscopic stuff or really huge things are going to use scientific notation. So scientific notation is always in the form of some number between 1 and 9 being multiplied by a power of 10. Okay? So when n is a positive exponent on 10, then what we do is we are going to move the decimal place to the right that many places. And then, of course, if n is negative, then we go to the left when it's negative. Okay? For example, we want to write 3.58 times 10 to the 4 as in standard form. So that exponent here, n is equal to 4. I know it's positive. So positive means move to the right. And if you're ever confused about this, just think about where positive infinity is and negative infinity. If it's positive, you're to the right. If you're negative, you're to the left. So that visual sometimes might help you. So now I know that I'm going to be moving this to the right 4 times. So 1, 2, 3, 4. So this is where my decimal is going to land. So what I need is space holders. And once I have my space holders, then I know that this is 3, 5, 8, 0, 0. So this is actually 35,800. Versus what I have over here, my next one, is look at my exponent. Here, n is equal to negative 4. It's negative. That means, since it's negative, I'm actually going to be going to the left. So it's slightly different. So I'm going to have my 3.58. Now I'm going to go to the left 4 spaces. So 1, 2, 3, 4. So now I have my placeholder. So this is 0.000. And I have my 358. So that's going to be my final answer. And that's what it means to write it in standard form. And we have some practice problems, which you'll also have in your homework. So I'm going to go ahead and skip those for now. But for example number 2, what we want to do is we kind of want to go in the opposite direction. Now we want to write the numbers in scientific notation. Remember, if it's scientific notation, it's always a times 10 to the n power, where a is going to be a digit that's less than or equal to 1, and it's going to be less than or equal to 9. Or actually, yeah, 9. Is that what it says? Let me see. I actually kind of wrote wrote this backwards. Oh, okay, so actually, good thing I checked. I had to make sure that it's strictly less than 10. So it's greater than or equal to 1 and strictly less than 10. So it can be like 9.8, 9.9, 9.9999999, but it has to be strictly less than 10. It can't be 10. It can't be 2 digits. It has to be a single digit number. So here, I'm thinking about this, and I'm like, okay, well, let's see. I know that it has to be 1 or bigger. So if it's going to be 1 or bigger, let's see how many times I have to move the digit over. So that's a 0, 0, 0, 0. Ooh, okay, that's the first non-zero digit. So that tells me that my decimal is going to be 6.08. And it looks like let's count how many times I moved this over. So it was 1, 2, 3, 4. Let me see, I lost my count. 1, 2, 3, 4, 5. So I went 5 places. So this is to the -5th power. Now I'm going to look at part B. If I look at part B, this number is definitely more than 2 digits. It has to be 1 digit. So, okay, let's see where it's going to be. So this is my decimal where I start behind the last digit, if it's not already given to me. So I'm going to move it over, keep going over. Well, if I stop here, that's 53. That's bigger than 10. Oh, so it has to be there. So now I know that I have 5.3 times 10. And you don't have to write all the trailing zeros. That's way too many zeros. So here, let's see how many times we actually moved it. It looked like we moved it 1, 2, 3, 4, 5, 6 times. So it's 5.3 times 10 to the 6th power. Okay. And of course, we have some practice problems, and you will have plenty of those to do on your homework. I just don't want to make this video too long. Okay? And actually, the next section is going to be section 5.2. So this is a good place to stop. So that is going to be the end of section 5.1, and I hope that you guys enjoyed our first video together.